Video will discuss about the vulnerability that is being caused by the delegate call. So whenever you are using the delegate call, you should make sure you should keep in mind two things. One, the delegate call preserves the context, and the second thing is it requests for the same storage layout in both the contracts. So now let's discuss this code which demonstrate the vulnerability that is being caused by the delegate call. So we have three contracts: lib, HackMe, as well as the attack contract. And as usual, we are starting with mentioning the license as well as the contract version. Anything above 0.8.17, we have up to 20, so that won't be an issue. And we have the lib function, lib contract. Inside that, we are specifying a public variable sum number, and we have a function doSum which is used to initialize this sum number. Okay, then once after deploying the lib contract, we are getting the address, and we are making, well, we are just using the address while we are deploying the HackMe contract. Here you can see we are initializing the lib contract inside the HackMe contract, and we are setting the owner, and inside the do something we are using the delegate call in order to encode with the signature, which is the do something, which is the function that is being called in the lib by passing the num as a parameter. So now we are going to discuss about the attacker. So the attacker has to change the owner variable, but how can he change it? So inside the attack function, we are mentioning the same layout, okay, same storage by layout that you can see in the HackMe contract. Okay, so let's discuss about the flow, right? So whenever the hack function is being called, it calls the do something, okay, from the HackMe contract. What does the do something do? It delegate calls to the do something which is present in the lib contract, right? So by passing the parameter address of this, so we have to make sure like it accepts the uint. So we are going to encode it into uint, enclose into uint. So we are passing address of this. Now it's not going to change the sum number inside the HackMe contract. Instead, it's going to change the lib variable, because it's like a slot 1, so and then slot 1, it's not slot 3, right? So that's very important in order to maintain a storage layout whenever you are using delegate call, which has not been maintained here. That's why instead of changing the sum number, here the lib is being changed, right? Now whenever you call the second time, now the lib is going to be the attacker's contract, right? Contract. Now we are passing the 1. Whenever this delegate call calls this contract, we are going to set the owner to the message.sender, and that is how we get access to this HackMe contract with the help of delegate call. So if you find this video interesting as well as informative, and try to leave a comment if you can, and make sure to subscribe my channels for further more contract related to smart contract auditing. So thank you for watching. See you on the next video. Bye bye.